You about to get schooled.
In order to complete your trigonometric substitution, you're going to have to be familiar with these three identities. The first one is the Pythagorean identity, and that is based off of the Pythagorean triangle. And the most common is sine squared plus cosine squared x equals 1. And then in order to simplify your trigonometric substitutions, you're going to know the power reducing formulas and the double angle identities. And that is just so you can convert the sine squared x and cosine squared x to the sine 2x and the cosine 2x.
This is an example of a problem that you have to use trigonometric substitution to solve. You know that you have to use trigonometric substitution because U substitution does not work for this problem. The first step to solving this problem using trigonometric substitution is to make your denominator look like one of the Pythagorean identities that you know. Since in this case you have a constant minus your variable squared, you know that you're going to use 1 minus sine squared as your Pythagorean identity. So you factor out a 25 in your denominator and you end up with the integral of 1 over the square root of 25 times quantity 1 minus x squared over 25 dx. So now that you've manipulated your denominator to look like one of the Pythagorean identities that you know, you're going to draw a right triangle to help you visualize the concept of this problem, since trigonometry is based off of right triangles. So, in your denominator you know that x squared over 25 corresponds to sine squared theta. Therefore, sine of theta equals x over 5 because you just take the square root. And sine of theta equals opposite over hypotenuse. So in your triangle, your opposite leg is x and your hypotenuse is 5. And then you solve for your adjacent leg, which is the square root of 25 minus x squared, and that's just using your a squared plus b squared equals c squared formula. So the next step is to write out some of the information that you already know and to find some information that you're going to need later in the problem. So you already know that sine squared of theta equals x squared over 25, and from there you can find that sine of theta equals x over 5. And then you have to solve for theta, which equals arc sine of x over 5, and you also have to solve for x, which is 5 sine of theta, and dx, which is 5 cosine of theta d theta. Now comes the actual substitution component of trigonometric substitution. You substitute in sine squared theta for x squared over 25, and you substitute in 5 cosine of theta d theta for dx. So you end up with the integral of 5 cosine of theta over the square root of 25 times 1 minus sine squared of theta d theta. And you can simplify that to the integral of 5 cosine of theta over the square root of 25 cosine squared theta, because that's part of your Pythagorean identity, 1 minus sine squared theta equals cosine squared theta. And then you can simplify that even further to the integral of 5 cosine of theta over 5 cosine of theta d theta, and the 5 cosine thetas cancel out, so you end up with the integral of d theta. The next step is to integrate your simplified integral, so you have the integral of d theta, which equals theta plus c. Now you've solved this indefinite integral in terms of theta, but your original problem was given to you in terms of x. So you have to use the information you recorded earlier, and you know that theta equals arc sine of x over 5, so you substitute in that for theta, so your final answer is arc sine of x over 5 plus c, and that is the solution to the indefinite integral initially given to you in this problem.
When you have an equation and you do not want to use U substitution, you can use trigonometric substitution. In this one, you have a constant plus a variable, so you're going to use tangent. The 1 plus x squared part of this equation closely mirrors the 1 plus tangent squared x equals secant squared x Pythagorean identity. Thus, in order to solve the equation, you're going to substitute the x squared for tangent squared theta. After you have written that x squared equals tangent squared theta, you're going to solve that equation for x, theta, and dx. X equals tangent theta, theta equals arctangent x, and dx equals secant squared theta. Because trigonometry is based off of triangles, it may be easier to draw out a triangle separating the equation. This is particularly helpful for any future trig functions in this equation. Because this problem uses tangent, the radical, including the constant and variable, will be on the hypotenuse, whereas the variable will be on the opposite leg of the triangle, and the constant will be on the adjacent leg of the triangle. In this step, you're going to plug in your newfound terms of x, theta, and dx into the original equation. As we have found before, 1 plus tangent squared theta equals secant squared theta, so we are going to substitute the 1 plus tangent squared theta under the radical into secant squared theta. Now we have found that we have tangent theta and secant cubed theta d theta. And so we're going to simplify that and change it so we have easier identities to secant squared theta and secant times tangent theta. Thus, we're now going to use u substitution in this equation. Plug in u to equal secant theta because we have secant in both of these equations. And then we're going to find the derivative of secant, which is secant theta tangent theta, and plug that into the integral of u squared du, which is 1/3 u cubed plus c. Plug in your known u, which is secant theta, into the equation 1/3 u cubed plus c. In order to finish the problem, you're going to have to solve in terms of x again. So you need to plug in using the triangle, you're going to have to plug in the hypotenuse over adjacent for secant, and that will give you 1/3 times the cubed of the square root of 1 plus x squared plus c.
I'm the one, creator of the heavens and the earth, Alpha and Omega,